All right, y'all. So like I said, 9.5 deals with properties of logarithmic functions. So remember, since logarithms are really exponents, they follow the same rules as exponents do. So the first one we got is what we call the product rule. And the product rule says if I got a log of a product, so log base A, M times N, then I can rewrite that as the sum of the logs. So I could do a log A, M plus a log A of N. Okay, so notice the factors were M and N. So we basically distributed the log A to both of them and rewrote it as a sum. So the product rule tells us to rewrite a product as a sum of the logs. And y'all, the second one is the power rule. So the power rule says if I got a log base A of M to the P exponent. So I'm raising P M to the P exponent. The power rule tells me to bring that P down to the front and write it as a product so that you get P times the log base A of an M. Okay, so that's the main thing. I'm just bringing the P down to the front and rewriting this as a product of P times the log A of M. And these properties, they're going to help us when we start solving equations next Monday, okay? All right, so we got the quotient rule. So if I had log base A of M divided by N. All right, y'all, so if I got the log of a quotient, I rewrite this as a difference of the logs. So once again, I distribute the log A to the M. So I'll have log A M minus the log A of N. And just like when you're dividing variables, you subtract exponents, it's always the top minus the bottom on these, okay? All right, the last one is what we call the log of a base to a power. So y'all, the log of a base to a power tells me if I have a log base A of A to the X, notice the base matches the base raised to X. This breaks down and simplifies to just X. And y'all, the reason is if you move the X to the front using that power rule, if you bring the X to the front, you have X times log base A of A. Well, remember the log base A of A part of that equals 1. So you would have X times 1, which is just X, okay? So those are our four properties we're going to be playing with. So y'all, let's get cranking on these exercises. So the first one says, express as a sum of logarithms. Now notice, the only property that has anything about sum of logarithms is this product rule. So they're going to give us a product and we're going to rewrite it as a sum of those logs, okay? So that's going to be my first two. So the first one, I got log base 11 of 11 times 121. Now, I don't have to simplify this one. They just want me to rewrite this as a sum. So y'all distribute the log base 11 to both factors. You'll get a log base 11 of 11 plus a log base 11 of 121. Now remember, we could go further on this, but they just wanted me to rewrite it as a sum, so I don't have to go no further, okay? Hey, also number two is a ln of d times f. Now, y'all, I've been having people have issues putting these answers in, but that is the ln, not an in, okay? So remember, ln. So my factors are d and f, so I'm going to distribute the ln to both factors and rewrite this as a sum. So I'll get a ln of d plus ln of f. Okay, y'all, so that's not bad. When they give you a product, rewrite it as a sum, okay? Now, the next one wants me to express as a product. Well, y'all look up here. The only ones that express anything as a product is the power rule. And all we're doing is bringing that P down to the front and rewriting it as a product of P times the log base A of M. Okay? So basically, that's all we're doing is bringing those exponents down. Now, number three, I got log base C of X to the 9th. All right, y'all, so up here, all I did, brought my P down to the front. So all I'm going to do is bring that 9 down to the front and rewrite this as 9 times the log base C of X. And y'all, that's all we got to do to that. Bring the exponent down, and now we have our product. And if you notice, they're alternating between doing logs and LNs to get y'all used to that lingo there, okay? So since that one was a log, this one will be an LN. I got an LN of the cube root of a 10. So y'all, here's the thing on this one. They got this one written as a radical. So before we can rewrite it as a product, we got to figure out what exponent's going to be out here. So let me recall y'all on something. And it's how to rewrite exponents using the radicals, okay? So if I got a nth root of A, now y'all, since the A don't technically have an exponent by it, we would treat that like a 1 under there. Okay, so this is like A to the first, and I'm taking the nth root of it. To rewrite this as an exponent, I would bring my base out, which is the a. And then we write the exponent as a fraction. The top number of the fraction is the exponent on the a. So since that's a 1, the top number at least has to be a 1. And then the bottom number of the fraction is equal to the index of the radical. So that would be n. So to rewrite a radical, you write it as a 1 over the index. Now, if I had another exponent by the a, that would be my top number. And whatever the index was would still be that bottom number, okay? So y'all, we're about to do that to this one. We're going to bring down the ln. We're going to bring out that 10. And what we need to figure out, what exponent am I going to rewrite this cube root as? Well, y'all, the 10 don't have an exponent by it.
So it's 1.
So 1, and then what's on the bottom?
3.
3, there you go. So now, guess what? We now have an exponent. So to rewrite this as a product, we're going to take that 1/3 and bring that down to the front so that we get a 1/3 ln of 10. So that's how we're going to trick y'all up on these, is maybe throw some radicals at you here and there. But y'all, once I get it out of those radicals, I'm then going to follow what rules I'm using, okay?
So that, excuse me, so that final one is going to be what you put into math lab?
You're going to put it just like this.
Okay.
Okay, so, yeah, that's it. Now, you'll see, once I do a couple of these where we're doing the difference with the quotient rule, then they're going to start mixing them up, and it gets a little bit trickier on them, okay? But right now, they're just wanting us to see the basic patterns on these. So we got the sums. We use the product rule. We got the product. We use the power rule. Now, we're going to express as a difference of logarithms. And notice the only rule that wrote anything as a difference was this quotient rule. And it's always going to be the log of the top minus the log of that bottom, okay? So let's see what they did on number 5. They got us a log base 3 of b over 3. Whoops, y'all, that's my bad. This right here was a log of a little b. So change that to a log base b, a little b of a capital B over 3. So this math lab is picky about small letters and capital letters, okay? So make sure y'all write this as a log of a little b, capital B over 3. So I'm going to distribute the log b to both factors and rewrite it as subtraction. So we'll get a log base little b of a capital B minus the log little b of a 3. All right, so I now have my difference. Final answer. All right, so let's see. They did a log on this one. So this one's going to be an ln of v over t. So y'all want to try one? See what y'all get on that ln of v divided by t? So remember, all I'm going to do is distribute that ln to both of these.
So it'll be ln v and then ln t.
ln v. And then what I want right here, though?
Subtract.
Subtract, there you go. And then ln
t
of my t. Okay. All right, so y'all, those are the basic things we're going to be doing to them, okay? So now they're going to start hitting us with just more than one thing happening at a time, okay? So let's turn over, and so 7 through 11, we're going to do something different with them. So from 7 to 11, we're going to rewrite these as sums or differences of logs. Rewrite as sums or differences of logarithms. And I'm just going to call that logs for short. So what this means, all four of them properties are now in play, okay? So number 7, they're giving me log base D of x to the 4th, y to the 8th, and z. So y'all notice, this is a product in these parentheses. When we had a product, we rewrote those as a sum. Okay, so remember, multiplication gets rewritten as sums, division gets rewritten as differences. So we're going to distribute the log D to all three factors and put plus signs in between. So I'll have a log base D of x to the 4th, plus we'll have a log base D of y to the 8th, plus we'll have a log base D of a z. So they're rewritten as addition because it was a product here. But y'all, there's one more thing I got to do with this. So we've already used our product rule. We don't have a quotient for the quotient rule. But what about that power rule? What did that power rule tell me to do?
You have to drop the base, the
Well,
base number.
I got to drop these exponents to the front of each of my logs. So y'all remember, if I got exponents on my variables, the power rule says bring them down in front so that we get 4 times the log base D of x, plus this one gives me 8 times the log base D of y. And then the z didn't have an exponent, so we'll just leave that a log base D of z. So remember, any exponents, when we're getting our final answers, we got to bring those exponents down, okay?
I got a question.
I hear you.
All right, so I understand that I understand that we did that, but why? So do you have to do all these 4 rules for every one of them for it to make sense?
If they apply. Now, I got some where we're going to use all of those rules.
So it's going to ask for like 3 separate answers.
Well, this is one solid answer here.
Okay.
Okay.
So we know to do that just because of rule 2.
Yeah, because what we had over here,
Right.
when we had a product, we automatically knew we had to write that as addition. That power rule told me, hey, if I got exponents, I got to bring them down to the front and write it as a little product there. And then if I got anything being divided, they're going to be rewritten as subtraction. Now, those 3 rules you're going to get hit with quite a bit, but sometimes we might have something that looks like this, log base A of A to the X, and that will just equal X in the long run. And you'll see at least twice. I got problems doing this right here also, okay? But focus on these three main rules at first when you get started.
Okay.
Now, watch this. We're about to up the ante on this next one. This number 8 has a log base b. Now, y'all, I got a fraction here. On top of my fraction, I got a p squared q7 over. Let me let one in real quick, y'all. What's got knocked out? Over M4 and a B8. Now, when you got fractions like this with more than one factor on top and more than one factor on the bottom, when I rewrite this, anything on top will be rewritten as addition. So the top rewrites as addition. The bottom of these, since they're on the bottom of the fraction, the bottoms will always rewrite as subtraction. Okay, so factors on top of the fraction, I'll make positive. These factors on bottom, I'm going to make them negative. And I'm going to distribute the log base b to all four of these factors. So y'all, here we go. We're going to start out log b of p squared. So we got log base b of p squared plus we'll have log base b of q to the 7th. These two factors are positive because they were on top. Now everything else is on bottom, so we're going to be subtracting those bottom factors. So minus a log base b of m to the 4th minus the log base b of b to the 8th. Okay, y'all. Positive factors on top, negative factors on bottom. So we're really following the product rule and the quotient rule on this. So notice this last part of this. I got that log base b of b to the 8th. What is this part going to equal in the long run? And that's when you need to think about that fourth property I said.
Is it going to be a 1?
Oh, you're close. The log b of b part makes a 1. But what's going to happen when I bring that 8 down? You get 8 times 1, which is just going to be
8.
8. There you go. So remember, if this base of the log matches the base raised to an exponent, this whole thing is just going to simplify to the exponent, okay? Now look here, none of these got bases that match. So for these three, what am I going to do? So now we're thinking power rule, right? Just like we thought over here.
And you put the exponents in the front?
I'm going to put the exponents in the front. So I get 2 log base b of p. Bring that 7 down. Plus 7 log base b of q. Minus, bring that 4 down. 4 log b m. Minus, what did we say was going at the end?
The 1 or an 8.
The 8. Because remember, that's going to equal that exponent since you got
So
that.
then the b, so it's like the b's cancel out?
The b to the b is that part that makes the 1.
Yep.
So
Okay.
this is just basically 8 times 1, which we're just going to write as an 8, okay? And y'all guess what? That's the final answer. Cannot do anything else to that, but we got to make sure we bring those exponents down, okay? So ain't they fun? All right, y'all, let me let one in real quick. All right, so let's see what they thrown at us. Another one similar to that. I got an LN this time, so they like to switch between these LNs and logs a lot. So this is an LN of 4 divided by 9x to the 9th times y. So I got one factor on top, 3 factors on the bottom. I got the 9, the x to the 9th, and the y. I'm going to distribute the ln to all the factors. And remember, the top factor will be positive. All 3 of these factors on bottom will be negative. So I follow that every time, okay?
So then it's ln plus 4.
ln of 4 minus
Minus the ln 9.
ln of 9 minus
ln x9.
ln x9 minus
ln y.
ln of y. And guess what? There's only one more thing I could possibly do to this answer.
Pull the exponents in the front.
Yeah, and the only one that's got an exponent is that.
4ln.
So that third one, we'll pull the 9 up. So ln of 4 minus ln of 9 minus 9 ln of x minus ln of y. So this one wasn't as bad as that one, because I didn't have any bases that matched like that one. But be careful, you do got to bring the exponents down and get to that final answer, okay? All right, now y'all watch this. I'm going to start messing with the radicals again. So for 10, we got a log of a square root a to the 7th b. All right, y'all. So the first thing you got to do is get rid of that radical by rewriting this. So I'm going to bring down the log. Now, since I got 2 things under the radical, I'm going to put that a to the 7th b in parentheses. But my question is, what exponent would I put here to rewrite this radical?
A 1.
So a 1 on top. What's going on the bottom?
The 7? No, 10.
So think about this. When there's not a number here on this radical, we automatically assume that that's a 2.
Okay.
So remember, a radical by itself does square roots, okay? So that would be a 2. So a square root would rewrite as 1/2.
Which is the one that we automatically assume is a 10?
Oh, that was on that log like this. If a log if a log didn't have a base, then we said that that would be a 10 there, okay? All right, y'all. So now what we got to do is distribute that 1/2 by multiplying by these exponents. So bring down your log a. Well, what is 7 times 1/2? Well, remember, the 7 multiplies by the 1. So I get 7 times 1 is 7/2. The b, so this b don't have an exponent, so you would treat that like a 1. And 1 times 1/2 is 1/2. So let me ask y'all this. These are being multiplied. So what will I rewrite that as?
The 7/2 log a, and then minus 1/2.
Oh, not minus. These ones are being multiplied. So remember, the product. So these will be added. So I would do log a to the 7/2 plus log b to the 1/2. Now,
So is it only if it subtracts, you put the exponent in the beginning?
when I subtract is when they're written like a fraction.
Okay.
But I got to do one more move to this.
That's where you have to pull out those exponents.
Yeah, so you still got to pull them out. I just wait till I rewrite it as adding first and then pull them out. But I think you was doing it all in one step, which you can do.
Yeah, I was.
Uh-huh.
So it'll be
Pretty
7
good.
over 2 log A.
7/2 log A. Now this one, since this log don't have a number here, it would be a what?
A 1. Or just oh, that's the 10.
That's the 10. Okay.
That's the 10. Okay.
All right, y'all. This one gives me what? A 1/2
Plus log. Yep.
log of a B. Okay.
So
They're just getting y'all used because we don't do a lot of radical stuff. So this why I go through these for sure because of them radicals. You always want to convert them into fractions. So if y'all ready for the good one then, right?
So the other one where the one you just did where you said that's where you would put a 10, you don't put the 10. You just know.
No, you don't have to. MATLAB knows if you just write log and then A, it knows that should be a 10 there. Oh, y'all, but watch this one. Log base A. Now I got big parentheses here. And I got a big radical here to the 4th root. Under this radical is an M20 and an N16 over A3 B5. So ain't that a dandy there, y'all? So the first thing I would do to this is rewrite this radical as a fraction. So let's bring down our log A. Now I'm going to keep this stuff in a parenthesis still because it's all up under that radical. So keep it in parentheses, but what can I rewrite this 4th root as? Well, that'll be what? 1 over?
1 over 4.
1 over 4. Okay, so remember, radicals, that index is always the bottom number of the fraction. All right, so now we got to distribute that 1/4 and multiply by every exponent under here.
So do you only multiply the top? So it's like the 20 times 1 and not the 20 times 4?
Right, you always do the 20 times 1. Now, I'll tell you what, since this is a 1/4, basically you're taking the tops and dividing by 4 every time. Okay, because 20 times 1 would be 20, but then that 20 divided by 4 gives me what, an M?
In 80.
M5. Remember, divide them by that 4.
Oh, okay.
N 16 divided by 4.
4.
Now on bottom, we can't really divide 3 by 4, so we'll just have to write that as A to the 3/4. And how about that B? Well, that's a 5 over 4. Can't do nothing with that. So that'll stay B to the 5/4. So yeah, when you got a whole number being multiplied by a fraction, you're basically dividing the whole number by the bottom of the fraction. All right, y'all, let's see if y'all get this part. These two factors on top will be added. These two factors on bottom subtracted. So let's distribute that log base A to the M5 plus the log base A into the 4th. And then we said these two would be subtracted. Log base A a to the 3/4 minus log base a of b to the 5/4. Now, you know what makes these problems look ugly, right? It's because you never get rid of nothing. You just rewrite it and then keep rewriting it and then keep rewriting it until you're done. But we don't never really get rid of anything, you know? Now, 3 of these I'm going to do something to, and then there's 1 of these that I'm going to do something different to. So guess what? I'm going to bring that 5 down. I'm going to bring that 4 down. And I'm going to bring this 5/4 down. But this one has a log base a of a to the 3/4. So remember, this is following my 4th property I gave y'all. And that's just going to equal 3/4 in the long run, okay? So remember, log base a of a to the 3/4. So I'm going to show you how that gets there. First, I'll bring that 3/4 down. But you got 3/4 times log base a of a, which is just a 1. So once again, this is just going to give me a 3/4. So that's what I'm going to replace this with right here. So I get what? A 5 log a of m plus, bringing that 4 down, I get a 4 log a of n minus, well, remember, this is just going to equal 3/4. And then minus, bring down to 5/4 log a of b. And y'all guess what? That is our final answer. So a lot of work on it when you got these radicals you got to get rid of, okay? Now, all the ones I've been doing have had a 4 here. Not to say you will, but most of these have had a 4. And remember, that 4th root rewrites as a 1/4, okay? So, y'all, that's the last of the ones where we had to rewrite as sums or differences. Now, we're going to go the other way and express them as a single log. So they're going to give me this kind of stuff, and we're going to go backwards this time, okay? So let's see. These will start at number 12. All right, and these ones will say express as a single logarithm.
Is it going to be that many steps like the other one?
These ones?
Yeah.
Well, they could be, because remember, if I'm undoing some of those, I'm going to have to follow them steps in reverse.
Yeah.
But these ones, they didn't kill us with too bad, okay? So let me see, what am I on? 12. Yeah, 14 and 15 will be the trickier ones in this section. And these go all the way to like 17. All righty, so here's 12. Log base t of 3 plus log base t of 79. So think about it. If we're going in reverse, you got 2 things being added. So to go in reverse, we're going to have to write this as a product. So we would have, huh?
So you subtracted?
Oh, no, we're going to rewrite them as a product. Because remember, I'm going in reverse of this rule right here, where they got 2 things being added.
Mm.
And remember, what I did, if I got 2 things being added, they're going to rewrite as a product being multiplied. So you'll take this 3 times that 79. Okay. But what is 3 times 79? So y'all, let's see. We got 3 times 79 because it wants us to rewrite it as them being multiplied. So 3 times 79 gives me a 237. Okay, so all we did was go in reverse of our product rule. All right, let's see this one. 13. I got log of 10,000 minus the log of 100. So since they're being subtracted, look at this. When they were being subtracted, they came from a quotient. The positive factor went on top. The negative factor will go to the bottom. So we'll have our log. On top will be the 10,000 divided by the negative factor, which goes to the bottom, which is the 100. So y'all, here's the question. What is 10,000 divided by 100? Ooh, so that's gonna be what? 100?
Yeah.
So that's the first answer it's going to want on that one. But guess what? This one simplifies further. So that's a log base 10 of 100. What exponent do you raise 10 to make 100? So how many times you multiply 10 times itself to get me 100?
It's 10 because they didn't understood because there's not a 10 base there.
Oh, no. Okay, so there is a 10 here, like you're saying, okay? But what I want to know is, what does this actual give me?
That's
Let's
gonna be
just-
2.
10 squared.
What did you
That's
just
just-
say?
It's
10
just 2.
squared.
So you would square that, so that means the exponent is a
2.
2. So remember, the log of 100 understood 10 there, but this simplified down to a 2. So 13 wants you to write it as the log of 100 first, and then simplify that on down to a 2, okay? Now this one I couldn't simplify because that was a t there. Okay, but this one, yeah, I could take that on down. And remember, you got that on your calculator there. Let me go to that calculator. So remember, we had a log right here on front, and then just punch in that 100. And y'all, that's going to spit out that 2 really quick, okay? Because remember, logs are finding exponents, okay? All right, so let's see what 14 has. Now 14 is going to give us a few more steps. I got 1/4 log C of X plus 4 log C of Y minus 3 log C of X. All right, y'all, so notice. The last thing I usually do is bring the exponents down to the front. Well, the first thing I'm going to do with this one is move the exponents back up.
Put them in there, yeah. So it'll be log C 1/4 of X.
X to the 1/4.
So,
All right, keep me going.
then it'll be log CY to the 1/4.
Oh, that's just a 4 there. So just bring up your 4.
Okay.
Minus.
And then you do the log C 1/4 rather than -3.
But just bring the 3 up and make that what, an X to the 3rd. Yeah, remember, these ain't radicals, so don't make them fractions.
Oh, because they're all separate. I thought they were all that. I
They're
thought they were
all
the
separate.
same
There you go.
exponent. Okay.
All right, now remember the positive factor, since I got adding and subtracting, I'm going to write it as a fraction. So bring out that log C. So this will look like a fraction. And remember, the positive factors will go to the top. The factor being subtracted will go to the bottom. So we will have a x to the 1/4, y to the 4th. They're going to stay on top. And then this one being subtracted, that x to the 3rd will go to the bottom. Now, y'all, I'll tell you what. This one, we're going to go one more step because I got an x here and an x here. I can't keep x's in top and bottom both.
So you cross them out.
Sorta. But what I'm going to do is take the bigger exponent, which is a 3. So that means the x will stay in the bottom because the exponent's bigger here. So what y'all need to do is figure out what 3 minus 1/4 will give me. So take the bigger exponent, subtract the smaller exponent, and whatever answer we get will go to the bottom. So that the
2/4.
only thing on top will be that y to the 4th. So what do we get when we do 3 minus 1/4?
2.75. Or you want?
Now make that a fraction.
11 over 4.
So 11/4. So if you turn the 3 into a fraction to match that, you'd have the 4 on bottom, multiply the top by 4, so you get 12 minus 1, which is 11 over that 4. So y'all, that's going to be the exponent of my x on the bottom. So just remember right here, we can't have the same variable on top and bottom. And think about it this way. This is bottom heavy like J-Lo. So I always call these the J-Lo. Since the bottom's heavy, the answer is going to stay in the bottom, okay?
Can you explain that other step real quick? Like once we reversed the exponent back, and then you did the log C, and then you did the fraction of x and 1/4. How did you get all that?
Okay, because remember, let me go back to my other page here just for a second. Remember when I had fractions to start with, and I rewrote them as differences and sums?
Yeah.
The factors that were on top were all positive. Any factors from the bottom were being subtracted. Just like right here, the p squared and the q7 were positive because they were on top. The m and the b were negative because they were on the bottom. Now look what we got here. I got a positive, this factor is positive. So those two being positive had to go to the top. This factor being subtracted right here, since it's being subtracted, that factor had to go to the bottom, okay?
So could you have 3 numbers, like say it was like all positives and 1 negative, you'd have all the positives on top?
On top and all the negatives on the,
Okay.
okay? And see, that's how I ended up with an x on top and then an x on bottom. And I had to sort of simplify them x's out to get that single x on the bottom with 11/4. And then all that was left on my top was that y4. So yeah, they're tricky, but a lot of this has to do with that simplifying the final answers on out, okay? All right, so watch this. 15. I got an ln of x to the 4th minus 3 ln a cube root of x squared. So the first thing I'm going to do is get rid of this radical. So y'all, we want to rewrite that cube root of x squared. So that'll be rewritten as an x. Now this time the x has the exponent of 2. So that 2 will go to the top. And guess what that bottom number will be?
3.
It's going to be that 3. There you go. So rewriting this part as that, I'm going to get an ln of x to the 4th minus 3 ln of x to the 2/3. All righty, so look what we got. What can I do to this? Well, I'm pretty stuck on the first one at the moment. I don't want to mess with that first one, but I'm going to do something to this second one.
Can you put the -3 over?
I'm going to bring that 3 up. So don't worry about that negative. Just move that 3 up there, okay?
Okay.
But what's going to happen when I bring this 3 up? I got 3 being multiplied by 2/3. So what's that going to give us?
That's just a 2?
That's just going to give me a 2. So this will give me an ln of x to the 4th minus an ln of x squared. So basically, y'all, when you bring that exponent up, all of these have canceled out, leaving just whatever was on the top, okay? So how would we rewrite something being subtracted? So let's go back. If something was being subtracted, I rewrote it as a quotient, right? The positive factor will go to the top. The negative factor will go to the bottom.
So how do you know you did the quotient for that?
So there's a minus right here.
Oh, because that's the only one with a subtraction in it?
That's the only one with a subtraction is a quotient. Okay. So knowing that, we'll have our ln. We got our quotient. On top will be an x to the 4. On the bottom will be an x squared. So we're pulling out the ln and rewriting the x4 over x2 as the fraction. Oh, y'all look at that. I got x's over x's. So y'all need to simplify that x to the 4 divided by that x squared. What will that leave me?
A 2?
X to the second.
X to the second. All right. I got me a single logarithm. So guess what?
That's the
Done
final
with
answer.
that. All right, y'all. So 2 more fun ones to go through. Okay.
Mhm.
And then I'll do my little bit of support for us. So 16. Same thing. I'm going to rewrite them as a single log. I got ln of x squared plus 16x plus 60 minus a ln of x plus 10. Now these ones say simplify the expression. So it looks like, yeah, 16 and 17 just say simplify the expression. But yeah, basically we're doing the same thing. Now, these are being subtracted. So we're going to write this as a quotient.
Quotient rule.
On top will be the x squared plus 16x plus 60. On bottom will be the x plus 10. So once again, the factor being subtracted went to the bottom. The positive factor went to the top. So we need to try to see if we can simplify this. And the only way to know if this will simplify is to factor that top. Because remember, to cancel the x plus 10, I'm going to have to get an x plus 10 as one of these factors on top. So let's see what we can factor the top into, because at the moment, we can't do nothing with the x plus 10 on the bottom. So y'all, that x squared is going to give us the x and the x. Well, both of these will be positive because the last number is positive. So both of these will be positive like the middle. Now I'm going to give you a clue. If it's going to simplify, it needs to be two factors of 60 that add to 16.
16.
Well, hell, one of them got to be 10, right?
Yeah, so it'll be 10 and 6.
10 and 6. So look at that, y'all. The 10s will cancel. Or the x plus 10s will cancel. So your final answer, now since we got two parts left, on 16, you got to leave that x plus 6. You got to leave that one in parentheses. So y'all 16, the trick is just going to be factoring the top, okay? Now 17 is going to be really similar.
So that ln x plus 6 is what you'd put in. That's the final answer.
Okay, that's what I would put in right there.
Okay.
And please use parentheses on it, okay? All right, y'all, look at this. A log of x squared plus 10x plus 21 minus a log of x squared minus 9.
What you write is a quotient.
It's a quotient. There you go. So we got our log. So
You
what you
got
putting
the
on
log.
top?
You're going to put all the positive of the x squared plus 10x plus 21.
On bottom.
The x squared minus 9.
So y'all look at this one. I got x squareds on top, x squareds on bottom. We got to factor both of these before we can tell that these will simplify. So bring out that log and let's see what we can do to the top. And the bottom is perfect squares. So it's going to factor out. So on top, I know I got an x and an x. That last one's positive. So both of these factors will be positive like that 10. So give me factors of 21 that'll add to get me a 10.
3 and 7.
So 3 and 7. Which means if this is going to cancel, one of these factors either better be an x plus 3 or an x plus 7. If I don't get those
Which is
down there,
gonna be
nothing will cancel.
Because it's 3 and 3 is
X
9.
plus 3, x minus 3.
Plus 3 minus 3. There you go. So perfect squares will always be conjugate pairs. Well, y'all look at that. X plus 3's gone. Now this one, MATLAB, I think, will let you put parentheses. But since I got a fraction left, I technically don't have to put the parentheses. Because if you're in fraction form, MATLAB will know that this is your numerator and that's your denominator, okay? So y'all, guess what? That was 9.5 college algebra. Now I'm going to go through 5 support questions. Yeah, support only had 5 in it, okay?
Good.
All righty, so let me pull that back up. So yeah, y'all, this is 9.5 support. And it was just getting you used to the exponent rules so that you would sort of know how to simplify some of these. And all these things simplify. But when you simplify, that means write everything with positive exponents. Now, number 1, I got x to the 5th times x to the negative 8. So let's think about that. I'm multiplying variables. What am I going to do with these exponents?
Multiply.
Yeah, make it positive.
Well, okay, I got to it eventually, but remember when you're multiplying variables, you add exponents. Okay.
You add them.
Oh, yeah.
So if I'm adding, what's a 5 added to a negative 8 give me?
-3.
Negative 3. Now, was it Dan? This is the point where I'm going to make these exponents positive. So remember, to make exponents positive, I basically flip stuff. So since this has got a 1 on the bottom, I'm going to make this a 1 over x and change that exponent from negative to positive. So if your exponent is negative on top like this, you put it under a 1 and make the exponent positive. If the exponent was on bottom and negative, you would move it to the top and make it positive. So you either move the variable down or up to change the sign. And that would be your final answer. So y'all, I'm following this exponent property right here. X to the negative a equals 1 over x to the positive a, okay? All right, y'all, the second one, try this one. Y to the negative 4 times y to the 9 times y to the 8. All these y's are being multiplied. What am I going to do with these exponents?
Add them.
Add them. There you go. So y'all, let's see what we got. 9 and 8 is what? That's what, 17.
It's gonna be 13.
And 17 minus that 4. 17 minus 4, that's what, 13?
Mhm.
Now guess what? That exponent's positive. So since the exponent's already positive, final answer. Okay, so we're only looking at this part of stuff if we end up with negative exponents as our results. All right, y'all, well, let's see. How about if I do a 9x squared times a 2x to the 4th. So before we can multiply these, we got to take care of these exponents. So these exponents are going to distribute. And remember, what does 9 squared give me?
18.
No, 81.
81. There you go.
Wait, 1. I'm sorry.
And now x squared, you're going to multiply these exponents. So that's what, an x to the 4th. So notice, when you got the variable times the variable, you add exponents. But when you got an exponent raised to an exponent, you multiply those. So that's 1 parentheses. Now let's work over here. What is 2 to the 4th power give me? So 2 times 2 times 2 times 2.
16.
Okay. Now remember, this x has a 1 for the exponent. So we distribute it. So now the x has an exponent of what?
4.
Because you multiplied those.
Sounds good.
Woo, y'all, I'm gonna have to break out a calculator on this because now I can multiply this. 81 times 16. Let's see. 81 times 16.
1,296.
X to the what?
X to the 4th.
Oh, you multiply them, so it'll be 12.
Or
So
X
X
to the
times
8.
X.
16.
You want to mess with me, bro?
Hold on, I got one being loud. Which one
Yeah,
is
that's
it?
sorry.
really loud.
Is it gonna be X to the eighth?
X
That's
to the
not my.
eighth.
Why you do that?
That's not my background though.
Uh-huh. Multiply the variables, you're adding exponents. Okay, I think I got it. All right, so y'all remember, when you multiply the variables, you're adding exponents, okay? You only multiply it when you got an exponent raised to an exponent. But when you're multiplying x's times x's, add those 4s and make that an 8, and that's your final answer. All right, let's see what we do here. B7 over B to the -2. Now, 2 ways you can do this one.
Don't you
The
divide
first
them?
way, this is the quotient rule. So if this is the quotient rule, what would I do with these exponents when I got a B over a B?
Cross them out.
Cancel.
Well, I don't, what do y'all want me to cancel?
The B's, but never mind.
Well, the B's don't have the same exponent, so I can't cancel them, remember? But here's the thing.
Yeah, okay.
Do you
Think about
subtract
this.
it?
When y'all multiplied variables, you added the exponents. You're dividing right here. When you divide, you subtract the
Subtract
exponents.
the exponent.
Subtract.
So what I got to figure out, what does 7 minus a -2 equal?
That would be -5.
So remember, you always take the top exponent and subtract the bottom.
9.
Yeah, because them 2 negatives make that like a big old plus, right? So that way you get B to the 9th. Final answer. Now, y'all, here's the other way you could have done this. Couldn't I have started out by making this exponent positive? And remember, to make this exponent positive, all I got to do is move that B up to the top. If you do that, you got a B7 times a B2. Well, what did you do when you multiplied variables times each other?
Multiplied. And then kept the B's and then multiplied the exponents.
Oh, you kept a B, but you didn't multiply these exponents.
You subtract them.
You added them.
I
7 plus
added
2
them, and that gave me B9. So either way works. You can do the quotient rule, 7 minus -2, and get that 9 and be done. Or you could have made the B -2 positive by pulling it up and then added exponents. Either way, we got a B9 on that, okay?
I got a question. So why is it B9 and not B5? Like if you do the -2 at the 7, so how come you just change it?
Well, remember, you're subtracting, so 7 minus a -2. When you subtract a negative, that becomes a positive.
Got it.
Now, for that to be a B5, you'd have had to have this B7 over a B2 positive. If I had this situation, this one would have gave me what, a B to the 5th, okay?
Got it. Yeah.
It's just because that negative on the bottom and we're subtracting that negative is happening. All right, y'all, so let's try number 5, the last one. So I got a 4x8 y6 all squared. So these were sort of getting us ready for the ones where I had the fractional exponents and had to do all that distributing. So y'all, that 2 affects that 4. So what is 4 squared?
16.
Now, on the x, you got an exponent to an exponent. So now, what is the exponent on that x going to be?
10.
6.
Oh. It's gonna be 10.
64, isn't it? And 8 times 8.
Well, not 8 times 8. 8
8 times
times
16.
2.
Oh, so you're not gonna add that.
16.
Okay.
No, remember, exponent to an exponent. If you got something like this, a to the m raised to the n, you're always going to multiply those. Okay?
Okay.
So the 8 times 2 makes that a 16. And how about that y?
12.
12.
That'll be a 12. So y'all remember, exponents raise to exponents, we multiply. If I had, say, x to the a times x to the b, that's where y'all added. Okay. If I had, say, x to the a over x to the b, that's where we subtracted. So notice, this one being multiplied because this is like having an a to the m times a to the m ever how many times that n is. So that's why we're multiplying those exponents. Now here, you physically got the x's times the x's. So you added those exponents, and then x's divided by x's. If you remember the one where I had like the x on top and the x on bottom, and we ended up with that fraction because we were subtracting exponents, okay? So this negative exponent rule and these three are basically what's happening on these problems, okay? All right, y'all. So that is the support doing these 5 questions. And then you had your college algebra, 9.5. So that's all I've got.